In Lesson 35, we'll be applying what we learned in Lesson 34 about factoring the greatest common factor out. Now, when we factor the greatest common factor in these problems, if you remember in Lesson 34, we would have a set of terms, and you would factor the greatest common factor of all of those terms, or you would find what the greatest common factor was. Now, factoring the greatest common factor, it's kind of like the opposite of expanding by using the distributive property. For example, if I had this relationship here, C times 2 plus AB, I could expand that using the distributive property, and I would say 2 times C plus ABC. Now I could reverse that. I could go backwards by factoring the greatest common factor out. And C, they both have a C in common, both of those terms. That's the greatest common factor. And so we would just say C times 2 plus AB. And see, that gets us back to our original expression that we had written there. So what I've written up there in red, that's something to keep in mind when you're factoring the greatest common factor out of a set of terms. It's like the inverse of expanding. And therefore, that's a way to check your work. After you've factored the greatest common factor from a set of terms, you can expand that problem back out using the distributive property to check your work. Let's go ahead and do a practice problem here. Let's factor this expression out. And so the first thing we want to do is figure out what the greatest common factor is between those two terms. We start with our numbers, 13 and a 39. So they both have a 13 in common. So we'll write that down. Then look at the x's. They both have at least an x in common. And then the y's, they both have at least a y cubed in common. And then the z's, one of them has a z to the fourth, the other one doesn't have a z term at all. So we wouldn't put any z in the greatest common factor. So there's our greatest common factor, 13x y cubed. Now, let's put some parentheses here, and we have to think about that first term, 13x squared y to the fifth. And so let's just write over here to the right-hand side the greatest common factor again, 13x y cubed. Now what would we multiply that by to get back to our first term, our 13x squared y to the fifth? Well, we'd multiply that by xy squared, right? That would equal 13x squared y to the fifth, our original first term there. So that's what goes on the inside of the parentheses, is this xy squared. And this is where it comes in handy to think about factoring being the inverse of expanding. You have to think, what would I multiply the greatest common factor by to get back to my original first term? And so we have that done. Now let's think about what would we have to multiply 13xy cubed by, our greatest common factor. What would we have to multiply it by to get that second term there? Well, we would need a negative 3. We know that. We'd need a negative 3 for the coefficient, because 13 times negative 3 is a negative 39. And then we wouldn't need an x, because it's just x to the power of 1. We wouldn't need a y cubed, because there's already a y cubed, but we would need a z to the fourth in there. And so we need to write z to the fourth, because 13xy cubed times negative 3z to the fourth is equal to that second term, negative 39xy cubed z to the fourth. We can expand that back out, that second term, just to make sure and check our work and make sure that equals that original second term, 13xy cubed times a negative 3z to the fourth. And so we look at that. 13 times negative 3 is negative 39. X, y to the third, z to the fourth. That is our original second term up there. So we know that we did that problem correctly. And so we'll go ahead and put a box around this answer right here. That would be the expanded form of that original expression. Let's do another one. Let's factor the greatest common factor out of this. set of terms. And so we look at the numerical parts first, and we find our greatest common factor. They all have at least a 3 in common, so we write a 3 down. And then we look at the x's. They all have at least an x. And then the y's, they all have at least a y. So 3xy is our greatest common factor. And so then we put some parentheses up here. And then we think about our first original term there, the 3x squared y. And we think, what would we multiply the greatest common factor by to get back to 3x squared y? Well, it would just be an x, right? Because 3xy times x is equal to 3x squared y. So we just have an x there. And then the next term, it has a negative sign out in front of it, so we'll need one here. And we think, what would we multiply 3xy by to get back to 3xy squared? And that would just be a y. Because 3xy times a negative y, that equals a negative 3xy squared. And then the third term, what would we multiply 3xy by to get back to 3x squared y squared? Well, that would just be an x times a y. Because 3xy is equal to 3x squared y squared. And so there's our factored form of that expression. Now, you may tend to want to just look at the problem in the problem set and not write the expression on your paper. I think that may cause a little bit of problem for you, because when you have it written down on your paper like we're doing here, you have that original expression written down, you can always be looking and referring right back to it. You can write your factored term right underneath it and then start to do your factorization. And I think it's just a whole lot more productive to have the original expression written on your paper rather than just referring back to your textbook every time. It takes an extra 20 or 30 seconds to do that, so try not to be lazy on that. If you're lazy when you're doing your math, that will hurt you later, and it'll cause you to make more careless mistakes than you really want to do. Let's do one more factorization problem. Let's factor this expression out. And so first, just like always, we want to find our greatest common factor. We start with our numbers. We look at the 6 and the 32, and we see that they both have at least a 2 in common. So we put the 2 out here. Then we look at the a's. They both have at least a to the 3rd. The b's, they both have at least b to the 5th. And the c's, they both have at least c to the 6th. So we have our greatest common factor now. We go ahead and put parentheses up here, and we think to ourselves, what would we multiply that greatest common factor by to get back to that first term, the 6a cubed, b to the 8, c to the 9? Well, we would need a 3 for a coefficient, because 2 times 3 is 6. We wouldn't need anything for the a term because it's just a cubed like it is in the greatest common factor. We would need a b to the 3rd, because b to the 5th times b to the 3rd would get us back to b to the 8th. And we need a c to the 3rd, because c to the 6th times c to the 3rd would get us back to that c to the 9th. Now, look at our second term, and we see that we have a negative 32. So we think 2 times what would give us a negative 32? That would be a negative 16. And then we look at our a terms, and we would need at least an a. We wouldn't need anything for b because it's already b to the 5th, and then we wouldn't need anything for c because it's already c to the 6th. So we're done. That's our expanded, or not our expanded, that's our factored form. Remember, we can always expand that factored form back out, though, to check our work if we need to. So when you're doing those problems, factor out the greatest common factor first, then figure out on the inside of the parentheses what 2 terms you're going to end up with that would get you back to the original of each individual term. Part B of this lesson is on canceling, and it also has to do with factoring a greatest common factor out. Now, if you had a fraction like this, 6 over 2, you know that you could cancel something in there because you have a factor that's in common with the numerator and the denominator. You could break that 6 into a 3 times 2, and then there's a 2 on the bottom there, and those would cancel. And we can always think of a 2 by itself as 2 times 1. So it really does have a factor 2, right? It has a factor of 1. And so the 2's cancel, and we end up with 3 over 1, or just 3. What I'm trying to show you here is that in order to cancel something, you have to have a factor in common in the numerator and the denominator. In this example, 5 over 2, there's no factor in common other than 1 in the numerator and denominator, so there's nothing to cancel there. So now let's look at a little more complicated expression. X plus 3 over 3. Compare that to 3x plus 3 over 3. And tell me which one of those can we simplify to a non-fractional expression. One of those we can, the other one we can't. Is it the one on the left or the one on the right? Well, it's the one on the right because we have a common factor there that we can factor out. We can factor a 3 out, and we have 3 times x plus 1 over 3. So we have a factor. 3 is a factor in the numerator and in the denominator. And so we end up with x plus 1 as a simplification of that fraction. In x plus 3 over 3, we cannot just cancel this and make that a 1 and end up with x plus 1. You can't do that because it's not a factor. It's added. That 3 in x plus 3 is added on to the x. It's not a factor. There's no common factor there. So what I have written up there in red is really, really important to remember. Only factors can cancel. And that's all. Nothing else can cancel. Add-ins like the 3 in the x plus 3, that cannot cancel with the 3 in the denominator of x plus 3 over 3. Only factors can cancel. So just to make sure that you know that, I'm going to put a big X through this one because that is an untrue statement there, what I've drawn. Look at practice problem D. What I want you to do is simplify that expression. And so you think about what you have to do to simplify that. You would factor something out. You're trying to get that into a more simplified form. Maybe just one term without it being a fraction, or maybe just a more simplified form of that. Maybe there's something you can cancel. And anytime you have a fraction that says to simplify, you're usually looking for something that you can cancel out. So look for a common factor in the numerator. There's a 3 in common, right? So you would factor a 3 out, and you'd have 3 parentheses 1 minus x over 3. And so now 3 is a factor in the numerator and in the denominator. Remember, we can always write that as 3 times 1. So now you have 3 over 3 that'll cancel, and you're left with 1 minus x over 1, or just 1 minus x. And so that's your simplified form there. So what we did there, we looked at those two terms in the numerator. We found the greatest common factor between those and factored it out. And only factors can cancel. So after we factored that out, we were able to see that we could factor that 3 in the numerator with the 3 in the denominator. We could cancel those out. Let's do one more. Look at practice problem E. 6x minus 18x squared over 6x. We want to simplify this expression. So the first thing we should do is look for a factor that we can cancel. And in the numerator there we have two terms. Let's see if we can factor something out of those two terms, a greatest common factor. Well, they both have a 6 in common, and they both have an x in common. So we could factor out a 6x. And so we'll have 6x parentheses 1 minus a 3x. And we always think about what we need to do to get back to the original two terms. If 6x is our greatest common factor, we would just, that first term, to get back to it, we would just have a 1 inside the parentheses. And then to get back to negative 18x squared, we have that negative 3x inside the parentheses. That would get us back to negative 18x squared. And then we just write it over 6x. And so now we see that we have a common factor between the numerator and denominator, so those can cancel. 6x over 6x. and we're just left with 1 minus 3x. Now I don't need the parentheses anymore. I just went ahead and wrote them, but you really don't need those parentheses after you've done your factoring and your canceling. After the canceling especially, you can get rid of the parentheses. The parentheses separate the two factors, but since you cancel them, you don't need them anymore. So in the answer key, if you wrote your answer with parentheses and the answer key doesn't have them, don't think that you did the problem wrong. Okay, well that's all for lesson 35.